Hello and welcome to Math 131. In this lesson we're going to be looking at an overview of Chapter 1, very basic stuff on graphs and graphing equations. We'll go over some terminology. A lot of this material will be things that you guys have learned about in the past, so it should be more or less a review. So we open up with the graph of an equation, and we talk about what it means to be a solution to an equation. So here we have an equation, 3x plus y equals 7, and we say that 2, 1 is a solution point of the equation. Often we just say 2, 1 is a solution of the equation. Okay, because if we plug in the 2 and the 1, it works out in the equation. Now you might say, what's 2 and what's 1? Right, so just to recap, when we have an ordered pair, which is what this is, a pair of numbers in parentheses separated by a comma, the first number is x, second number is y. Okay, and when we plug the 2 in for the x, we would have 3 times 2 plus 1 for the y. And so we figure out 3 times 2 is 6, 6 plus 1, 6 plus 1 is 7. So we know that 2, 1 is a solution to the equation 3x plus y equals 7. Okay, and a lot of times to graph an equation we create a table of values. If we're not familiar with the model of that equation, like if we are not familiar with a line or a quadratic parabola, we create a table of values, and then based off of those values we plot the points, and then we draw our graph. Okay, so we say that the graph is the set of all solution points of the equation. Okay, and in this particular graph this looks like a line. If we're looking at it from left to right, it slopes downwards. It crosses the y-axis at 0, 7. And it crosses the x-axis somewhere between 2 and 4, closer to 2. Okay. So let's take a look at an example. To sketch the graph of y equals x squared minus 2, first construct a table of values. Okay, so y equals x squared minus 2. So now here we have our x values predetermined. You could choose other x values. I chose these so that we could see the clear picture of the graph. Okay, so for the first one, we plug in -2 for x. So it's -2 squared minus 2. And then we evaluate this with order of operations. Exponents, so -2 squared is positive 4 minus 2. And 4 minus 2 is 2. Okay, next plug in -1. So we have -1 for x squared minus 2. -1 squared is 1. 1 minus 2 is -1. Plug in 0. Y equals 0 squared minus 2. 0 squared is 0. Minus 2 is -2. Plug in 1. Y equals 1 squared minus 2. 1 squared is 1. Minus 2 is -1. And then plug in 2. Y equals 2 squared minus 2. 2 squared is 4. 4 minus 2 is 2. Okay, so let's graph these ordered pairs. We have -2, 2. So -2, 2. -1, -1. So again, we start at the origin, go left 1, down 1. 0, -2. So we go straight down 2. 1, -1. And 2, 2. Okay, so we see that it creates this U-like shape if we connect our dots. And most of you will know that this is a parabola, right? This graph is a quadratic equation, meaning that the highest degree term is an x squared, or a quantity squared. Degree is a 2, second degree polynomial, and the shape of this is a parabola. Okay, so that's how we graph intercepts. When we look at intercepts, we mentioned this earlier. We have a x-intercept when a graph crosses the x-axis. For example, this graph would have 3 x-intercepts. If the graph crosses the y-axis, it would have a y-intercept. Okay, and some graphs have both x-intercepts and y-intercepts, and some graphs have no intercepts. Okay, so let's talk about how we get an x-intercept. The rule is very simple. To get an x-intercept, make y equals 0, and then we solve for x. Okay, and same is true vice versa for y-intercept. To get the y-intercept, make x equals 0 and solve for y. Okay, so let's take a look at this equation. Let's get the y-intercept. Y-intercept would be to make x 0. So make x 0, that means we have y equals, just plug in 0 for x. So we have 0 cubed, which is 0, minus 4 times 0, which is 0. So we have y equals 0. So y equals 0, that's our y-intercept. So that means the point for the y-intercept would be 0, 0. Okay, x-intercept, we make the y 0, so replace y with 0 and solve for x. Okay, so now to solve this for x, we use a lot of our techniques we've learned from Algebra 1, Algebra 2, pre-calc. To solve this, we could factor out an x. So when we factor out an x, we're left with x squared minus 4. And if there's any part that could be factored further, we continue. Right, so the inside here, x squared minus 4, that's a difference of squares. So we have x plus 2 and x minus 2. Okay, and now that we have our expression fully factored, we can set each of our factors equal to 0. Okay, Okay, so we have 3 factors. That means we'll have 3 x-intercepts. We have 1 at x equals 0. When x plus 2 equals 0, we would get -2. And when x minus 2 equals 0, we would get +2. Okay, so our 3 x-intercepts would be 0, 0, -2, 0, and 2, 0. Okay, so notice one thing, 0, 0 happens to be both an x-intercept and a y-intercept. And that happens sometimes. Sometimes certain points can double up and serve 2 or more roles. Okay. Symmetry in a graph. Sometimes we talk about symmetry when we're graphing. If you have a graph and the graph appears to be symmetric about the y-axis, it means that if we have -x and we plug into the equation, we get y. It would mirror the same point as if we put the +x into the equation. Okay, so the graph we graphed earlier was symmetric about the y-axis. Okay, because when we put in -2, we got 2. We put in +2, we also got 2. So, and you can see that the y-axis acts as a line of symmetry. It seems to divide the graph right down the middle, creating 2 mirrored pieces on both sides. Okay. X-axis symmetry. So if a graph is symmetric about the x-axis, similar idea as the y-axis. This time you have the x-axis acting as the line of symmetry, so that you would see mirrored images above the x-axis and below the x-axis. And then symmetry about the origin, we would have an image like this, where if you plugged in -x, -y into the function, the opposite of that would be true when you plug in +x, +y. Okay, so a function like this would have more of a rotational symmetry, if you want to think about it. If you rotated this figure, this graph, 180 degrees upside down, it would look exactly the same. Okay, so that's symmetry about the origin. So this is one particular graph. Another particular graph that comes to mind is y equals x cubed. If you guys want to play around with that and verify, that graph also has origin symmetry. Okay, so this was just a brief overview of chapter 1. We get into the real meat and potatoes in chapter 2, so we'll continue with chapter 2 when we meet together in class. Okay, have a good day. We'll see you soon.